This is how to do password-based encryption for an SQL database without suffering a great deal of performance hit, and also to include read and write ACLs, read and write permit. So a typical SQL row will look like this. You'll have probably a incremental ID, and then you'll have some key that you want to search by. But then for encrypted database, one that's not the whole database encrypted, but each individual row, it would look like this. Column 0, 1, 2, 3, etc. would just be password-based encrypted. And you need some way to search for this if everything's encrypted. So technically this key will probably not be here, or it'll be too encrypted to do searches on it. You could do binary searches of digests, but that's perhaps not the fastest way to do it. What you probably wanted to use is B trees. So what you'll do is have a B tree index of the key that's been encrypted. So what you'll do is when you want to insert or find a row in the database, you will traipse through the tree, decrypting with the asymmetric key A until you find your location where your new key fits. And then you'll have a row ID in a bucket for that key, like that. And if it's in an insert, you'll find your location, perhaps a new location here. But you'll have to encrypt with B to insert. So now you have decrypt with A to find your location and read the database. You have encrypt with B to find the location to insert. So the write permit is with B, read permit is with A. So where can you keep these that they somehow form some form of permit? Well, what you will do is allow people to password-based encrypt those when you grant that right to them, and keep them somewhere in another table that they can only recover with their password, basically. And you can use very strong, capable password recovery or finding schemes to make sure they don't get lost and lose their access to the database. Of course, there will perhaps be a master key that can reassign them if the password's lost. But anyway, A is read, B is write permits for a row that's been encrypted. And you will also probably not want to use asymmetric encryption. For those, you'll probably want to use another key, and that can just be encrypted the same way. You'll assign a password-based encryption to that, and they can thereby decrypt the rows. And that's, of course, mostly read. You'd have to do it for writes. But since it's symmetric and it's going to be very fast, that affords very quick recovery of the data in the rows once you know what ID to look for. That's how you do ACLs. And the reason you want to use passwords-based encryption is because passwords are virtually impossible to steal. Most other things can be stolen, such as tokens, telephones, post-it notes on the screen. Don't use those. About any other form of access can be stolen, but a password exists only in a human being's brain. So that's the motive of that. And you use this asymmetric key to have both a read and a write version to form the tree and insert the data or read the data back.